Hi there, in this screencast I'm going to do some sample problems that will be similar to the free response questions on the final exam. So let's get started. Okay, the first one I'm asked to graph a square root function. So I think on the exam it'll ask you to graph the parent function and then the shifted function. So to graph the parent function for when you're talking about a square root, I'm going to draw a table of values and use 0, 1, 4, and 9 for my x values. Oh, and first of all, the parent function doesn't have the -1 or the +5, so it's just y equals the square root of x. So I'm going to put in 0, and I'm going to get 0 for y. Then I put 1 in, and I get 1. When I put 4 in, I get 2, and when I put 9 in, I get 3. So those are my points. 4, 2, 9, 3. So I'm going to connect the dots. And notice that the function does not exist when x is less than 0 because you would get an imaginary value for y. Okay, so now I'm going to shift the function. So when I look at this, this determines the x shift, the number that comes right after the x. So that means 1 to the right because it's the opposite for x of the sign as far as the direction. So minus for x is normally the left, but you do the opposite. It's 1 to the right. And then I'm going to go 5 up. So the number on the end means how many um, uh, values I shift vertically. So I'm going to shift each point 1 to the right and 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. And then this one's going to be a little bit off. So I'm going to get something like that. And then I'm going to, the domain and range for this, well, for the domain, you want to look and see which values of x, when you go across the x-axis with a vertical line, and you look up and down, when do you see, what values of x do you actually see the graph? And for this one, for the shifted function, it's only going to be when x is greater than 1, greater than or equal to 1. The graph does not exist anywhere to the left of where x is greater than 1. So I would write the domain as all real numbers greater than or equal to 1. And then the range, likewise, it's you do the same thing except use a horizontal line. And you're going to see that the only place where, when you look left and right with a horizontal line, that you see the function, a point on the function, is where y is greater than or equal to 5. So the range then would be all real values greater than or equal to 5. Okay. Find four consecutive integers whose sum is negative 218. So this is a classic problem of the consecutive integers. So I'm going to make my integers be x, x plus 1, x plus 2, and x plus 3. And when I add them, I get negative 218. So I'm going to add them together, and I set that equal to negative 218. Negative 218. Okay, so now I'm going to simplify, and I'm going to get 4x plus 6 equals negative 218. So I'm going to subtract 6 and get 4x equals negative 224. So then I'm going to divide by 4, and that's going to give me x equals negative 56. So that means my consecutive integers are negative 56, negative 55, negative 54, and negative 53. All right. Okay, the next one is Brian is 3 years older than 4 times Sydney's age. So I think I told you, you always want to make the variable be the person that comes after the word than. So if I make Sydney be X, then Brian is going to be 3 plus 4x. And the sum of their ages is 55. So that would be 3 plus 4x plus x equals 55. So that's 3 plus 5x equals 55. So I'm going to get 5x equals 52. So that means x is 52 divided by 5, which is, let's see, it's 10.4. So one of them is 10.4, and the other one is going to be 3 more than that. 3 more than 4 times that. So that would be, let's see, 41.2 plus 41.2 plus 3, it would be 44.6. Is that right? Let me see. 3 more than 4 times 52. Yeah. Okay. So 4 times that. No, that's my problem. 4 times that is 41.6. So 41.6 plus 3 is 44.6. No, 45.6. And if you add those together, you do get 55. Okay, so Sydney is 10.4 years old. Brian is 44.6 years old. Okay, then we have a rate time distance problem. Okay, so this is an out and back problem for rate time distance. So you always want to set these up where you make a little table and you do rate times time equals distance. So I'm going to make one be going and one be returning. Okay, so let's see, how many hours did the trip going there take? So that means I'm going to make x be the time for going. Okay, a freight train, it took 3 hours longer to go than it did to come back. So if going is x, and it took 3 more than returning, then x minus 3 would have to be the returning. The average speed on the trip there was 28 and on the back was 40. How many hours did it take? So going is 28, returning is 40. So that means this distance is 28 times x, because you always do rate times time equals distance. That's how you always fill in the last column. And this would be 40 times x minus 3. Okay, so how many hours did the trip take? Well, the distance is going to be the same either way. So your equation is 28x equals 40 times x minus 3. And then you solve that equation, you get 28x equals 40x minus 3. And I'm going to, let's see, subtract, oh no, I'm sorry, 40x minus 120. That's better. So let me subtract 40, move the 40 over to the left. That's going to give me negative 12x equals negative 120. Divide by negative 12, and I get x equals 10. So that means how many going took 10 hours. So that would be 10 hours. All right, and then, okay, so this one is, the next one is going, two people traveling in opposite directions. Okay, so once again, I'm going to make up my little table of rate, time, and distance. So rate times time equals distance. Okay, and then I have two people. I have Wong and Ashley. Okay, so find the number of hours Ashley traveled. So I'm going to make her time be X. Okay, now I need to figure out what the other things are. Okay, so Ashley left traveling in the opposite direction at 77, and Wong went 61. Okay, so, and how fast, what time? Sometime later, Ashley left. Wong left home for 6 hours. Okay, so Wong went for 6 hours. So that means her distance is going to be 6 times 61, which is 366. And Ashley's distance is going to be 77x. So since they're going in opposite directions, I'm going to add the expressions together. So one is 366 and the other one is 77x. So when I add those together, I get the total distance, which is, what was it, 520. So now I'm just going to solve that equation. So I'm going to subtract 366 and get 77x equals, and then let me bring up my calculator. Where is it? And I don't have it, so let me bring up the on-screen calculator. So I'm going to do 520 minus 366. So I get 154. I'm going to divide by 77. So that means x equals 2. So the question was, find the number of hours Ashley traveled. Well, her time is x, so that means she went 2 hours. Okay, but just to review, the key to doing the out and back problems is to equate the distances to get your equation. So you basically, for all these problems, you fill in the rate and time portions. You make the distance be rate times time. And then for out and back problems, you equate the distances to get your equation. And for going in opposite directions, you add the distances together to get the total distance. Okay, and then the last problem is a rational equation here. So I'm going to need to find the least common denominator. So the least common denominator is going to have one of each item that's in each denominator, one of each factor. And if a factor occurs more than once, you would have to have it that many times. So here I have a 3 and an x. The most that either of them appear in any denominator is once, so I'm just going to leave it 3x. If the problem had a 2 there, then it would have to be 3x squared. But it's just going to be 3x for this one. So I'm going to multiply everything by 3x over 1, and I distribute. So I get 3x over 3 plus x minus 5 times 3x over x equals x plus 2 times 3x over 3x. So that's just multiplying. When I distribute, I'm multiplying two fractions together for each term. Okay, so now I can simplify And this just leaves me with x plus x minus 5 equals x plus 2. So that's 2x minus 5 equals x plus 2. So now I'm going to add 5 to both sides. And I'm going to subtract x from both sides. So that's going to give me x equals 7. And that's my solution. All right, hopes this was helpful. And the problems on the final exam will be right along those lines. So it'll all be over tomorrow, and you're all ready to graduate. Cheers.